Welcome back, Math 10-3. Today we are starting our new chapter, chapter 9. And I believe chapter 9 will be our last chapter for this course. And when it comes to chapter 9, the title is Similar Polygons. So as you may notice, we are going into the world of geometry. So last time when we touched base about geometry was Pythagorean theorem and SOHCAHTOA, which is trigonometry. So this is our last. Transformation part is technically what you learned before. It is a little bit going beyond about what we're learning in chapter 9, so I prioritized. Chapter 9 should be more significant. As you may notice, it does play a huge role when it comes to angles and ruler, those kind of things. So I'll put some material that you need. Ruler, protractor. These two, you need to basically have it right next to you. And the page that you should go is workbook page 242. I am using blank pieces of paper with a little bit of a snap of what I think is significant, so have that in your mind. Chapter 9.1, the very first lesson, talk about identifying similar polygons, folks. So that means we need to compare. When it comes to mathematical comparison, we are basically using larger than, smaller than, equal, and unequal. So if it's a symbol, larger than, smaller than, equal, or unequal, you know these signs. Some people learn it as alligator signs. Oops, sorry about that. So basically, when you try to compare things, and even before identify, oh, this polygon is similar polygon or identical polygon, something like that, you need to understand how to compare. So let's talk about each of these, try these question on page 242. The question says compare, write equal sign, unequal sign for each of them. We're gonna look at it a little bit differently. We're gonna develop why they are equal or unequal. So let's talk about that. 1.9 and 190%. Let's talk about these two differences. One on the left is obviously a decimal. One on the right is obviously a percentage. So both basically talk about the ratio. It's a comparison, mathematical comparison. So what you need to do is if you have a percentage, it's a good idea to convert it by divide everything by 100 and figure out whether the decimal matches together. 190 divided by 100 give you 1.90. So now 1.9 that we have and 1.90, these are essentially equal together. They are identical. It just rounded up to a tenth, rounded up to hundredths. That's the only difference. So you can put the first example are equal together. Now next question. We have fraction that we are comparing on the second scenario. When we compare fraction, I like to give you the idea that simplify the fraction. What I mean by that is 1 over 4 should remain as 1 over 4 because 1 and 4 there's nothing in common. But 4 over 12, you can divide it by 4 on both sides. When I say both, on the top and the bottom, 4 divided by 4 turn out to be 1. 12 divided by 4 turn out to be 3. So now we can compare 1 over 3, 1 over 4, are they equal or not equal? It's not equal. In fact, 1 over 3 is bigger. So you can just put does not equal sign above. Let's look at the other part. Fraction, decimal. If you have fraction, please convert it into decimal. But before we convert, if I have 10, 100,000 at the denominator, everything is easy, but we don't. So I will multiply everything by 2. 3 times 2 is 6. 5 times 2 is 10. Then we know that 6 over 10 is equivalent as 0.6. And as you may know, 0.6 is larger than 0.3, so you can just put not equal to. On the other hand, I have percentage, then convert it back to our decimal, divided by 100. Then you will know that it's just whole number 1. It's not equal to 100. In fact, 100 whole number is bigger than 1. So I can just put they're not equal. Now, why did I focus on the very first page, try these, which sometimes I omit and then straightly go to the lesson, is because when we compare polygons, we have to mathematically compare, and there are two things that we need to compare. Number one, angle, and number two, lines. We have to compare these two properties. Without further ado, let's go to a classic example that is available on page 243. A graphic artist created these shapes. Are they similar polygons? So right now I have angles at A, B, C, D, J, K, L, M. So one thing that we can do is compare angles. And another thing that we can do is compare length of line, but I like to say bracket ratio. So what I mean by that is this. As you clearly can see, length of AB and JK, these are different. But how much in terms of ratio, AB is longer than JK, so we're gonna compare the ratio of difference of these two. We're gonna look at these two, these two, these two. So have that in your mind. Let's take out your ruler too, in fact. My ruler have basically measurement and the angle together too. So have that in your mind, just double checking. It's slightly off from the 60 millimeter for me. So it can be a little bit debatable, but let's just go through everything like the way it should be. That's 4.5, so it's about 3 millimeter differences, eh? Yeah, 3 millimeter differences. So let's do something that is obvious first. Angle. Angle A, angle J. We're gonna look at what I like to call corresponding angle. It's a fancy way of saying it's the same angle in a different polygon. So A location up left, J location up left. DM, those are corresponding. CL corresponding. D, B and K corresponding. So I'm gonna put D, M, C, L, B, K, something like that. So that I'm gonna put equal sign, not equal sign, those kind of thing. So by the way that I'm writing is different than the textbook, of course, so have that in your mind. Highly recommend that you use blank pieces of paper with the example, or just blank pieces of paper with the page number in question is okay too. Angle A. If I look at it, that angle is exact 85. Oh, sorry, 105. It passed 90 degree. And if I look at J, it have located itself as 105. So these two angles are equal, and that's 105 degree. Put it at the side. D, look at the angle. It is located at exact 100. I hope you can see the whole measurement. It's located at, I need to extend the line. It's located at 100 also. Angle D and M, identical. C, it's located at 100 again. L, same thing, 100 over there, as you can see. So they're equal together as 100. Shouldn't have that angle sign for the number part. B and L, it's located at 55. Located at 55. 55 degree. So long story short, when it comes to similar polygon, they share corresponding angle, and quantity should be identical. So I like to say similar polygons share identical corresponding angles. That's one conclusion. Now, let's do a tricky part, our second half. So first half was an angle. Second half, it will be length comparison. Let's go through what we have first of all. AB, 60 millimeter, and corresponding line is what we call JK, that's 45 millimeter. First of all, the matching lines, if you will, is known as corresponding side. Now, we need to know the ratio. 60 to 45 is what you need to know. As you may notice, 60 and 45, those are not the most simplified number. So what you can do is, I'm gonna divide it by 5. Same thing you gotta do. Then 60 divided by 5 is 12. 45 divided by 5, that's 9. Apparently we can do one more by divided by 3 for both. Then you will have 4, 2, 3. So long story short, as long as we get 4 to 3 ratio for every single other side, then that will make and prove mathematically that diagram that you see ABCD and diagram that you see on the right side JKLM are similar polygons. You can conclude it in that way. So let's measure B and C. By the way, first of all, I'm gonna modify a little bit, because this printed one is about 0. It's about 2 millimeter off, 2 to 3. So have that in your mind. That's about 3. No, that's a 4. So whatever it's plus 3, yeah. That's about 40 millimeter, 30 millimeter, 4.45 millimeter, 335, actually 35 mil, 15 mil, 18 mil, 12 mil, 1.13. Yeah. Although I don't think I measure in a good way, because my diagram is a little off, but in any case, let's compare BC and KL. 40 mil, 30 mil. We're gonna compare these two. Then followed by, I'm gonna write down first CD, which is 45 mil, ML, which is 35 mil. We're gonna compare this corresponding side. And our last AD, JM. I am really doubt about this measurement, so let me quickly measure this again. Maybe it's 19. And this is 13. But anyway, that doesn't seem right. 16 and 12 may be right. But anyway, then let's go with 16 and 12. So, let's compare. First thing first, 40 to 30. I can just divide everything by 10 and 10 to simplify. So 4 to 3 ratio is what I have for BC and KL. So these two matches CD and ML. That's 45, 35 divided by 5 divided by 5. Then I have 9 to 7. These guys doesn't match necessarily in here, and who knows, it can be my mistake too. Oh, it must be right, it must be 44 and 33. Can you change it? Because according to the question, it seems like those two are corresponding. So 44 divided by 11, yeah, it's 4 to 3. That's also match. Sorry about that. Again, that's a little problem if you print something and then try to match with the scenario. The fourth one, honestly, I'm not too sure, just because my ruler seems like it's not correlate to the measurement in the question, but 16 to 12 divided by 4 for each, then you have 4 to 3. So you know what? There you go. Everything matched with 4 to 3, 4 to 3, 4 to 3, 4 to 3. So I can conclude, sorry about the third one, I can conclude that similar polygons have an identical length ratio for its corresponding side. That's what I want to point it out to you folks, and that is today's lesson. Your to-do list is completing page 244 to 245 of your workbook question. Those have about 5 questions.